So my name is Sakesh Shetty from AJIT Engineering College, Bangalore. Today I am going to teach what do you mean by specific energy. So this is the datum line. Datum line means the bottom, it is Earth surface, and this is the canal tank. Canal tank is not resting above the the surface. It's having some inclination because the water is flowing by gravity. So that reasons some having some inclination, that is theta. And what is the height? Height is z. ಇಟ್ ಮೀನ್ಸ್ ಯಾವುದೇ ಕೆನಲ್ ಆಗಿರ್ಬೋದು, ಯಾವುದೇ ಫ್ಲೋ ಆಗಿರಬೇಕು, ಭೂಮಿಯ ಮೇಲೆ ಎಕ್ಸಾಕ್ಟ್ ಇರೋದಿಲ್ಲ, ಸ್ವಲ್ಪ ಇನ್ಕ್ಲೈನ್ಡ್ ಆಗಿರ್ತದೆ. ಆ ಹೈಟನ್ನು ನಾವು ಝೆಡ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಇಟ್ಸ್ ವಾಟರ್ ಫ್ಲೋಯಿಂಗ್ ಹೈಟ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಚ್. ದಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಎಚ್. ಸೊ ಆಫ್ಟರ್ ದ್ಯಾಟ್ ದಿ ಹೈಟ್ ಆಫ್ ದಿ ವಾಟರ್, ಆಫ್ಟರ್ ದ್ಯಾಟ್ some flow is there, some head is there. That is the datum head, and this is the potential head, and this one is kinetic head, that is called v square by 2g ಅಂತ ಹೇಳಿ ಬಂದು ಸ್ವಲ್ಪ ವೆಲಾಸಿಟಿ ಹೆಡ್ ಇದೆ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಆ್ಯಕ್ಚುಲಿ ಇರೋಲ್ಲ, ಅದು ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ದಟ್ ಕಾಲ್ಡ್ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್. So that till here we can find it, okay, height of the water. After that some velocity head is there, that we calling imaginary line, that is called v square by 2g. That is we can write it, total energy is equal to total energy is equal to total energy line is equal to total energy is equal to z plus h plus v square by 2g. V square by 2g, v square by 2g. So velocity head, that is velocity head. So but what is mean is specific energy? Specific energy means when we are just ignoring this z, we are considering only the resting, we are considering only h plus v square by 2g. Only velocity head we are considering, and we are ignoring this one. We are considering only this part. It means it's having only, it's resting on the bottom of the datum line, and the exact above the datum line, and we are considering h plus v square. That is not necessary to consider z. That we are calling specific energy. ಅದನ್ನು ಸ್ಪೆಸಿಫಿಕ್ ಎನರ್ಜಿ ಅಂದರೆ ಝೆಡ್ ಅಂತ ನಾವು ತಗೊಳ್ಳಿಕ್ಕಿಲ್ಲ, ಡೇಟಮ್ ಲೈನ್ ಅಂತ ತಗೊಳ್ಳಿಕ್ಕಿಲ್ಲ. ಇಲ್ಲಿಂದ ನಾವು ಇದನ್ನೇ ಡೇಟಮ್ ಅಂತ ತಗೊಳ್ಳೋದು, ಇಲ್ಲಿಂದ h plus v square by 2g. That is called specific energy. That line is called specific energy. Specific energy, and this one we are calling when the water, when the velocity, what means energy is creating from the height of the water, that is called from the height of the water, that is called potential energy, and then kinetic energy. So whatever energy we need to calculate, using this one we are using for calculation of energy, we are using this one. That is specific energy is equal to potential energy plus kinetic energy. So bottom of the tank, what energy is producing, that we need to measure. Using this method we can measure the energy. Okay, the bottom of the tank energy. But height, if b is equal to, for example, p is equal to, we are having p is equal to rho gh. So we need to calculate the pressure of the bottom of the tank here. So same thing here also we calculate the energy. Pressure, we need to calculate the pressure also we need to calculate. So how we can calculate? We know the h, lu, and we have density and 9.81. we can calculate the pressure, right? No, yes, p is equal to rho gh. G is 9.1000 and h is height of the water. We can calculate the pressure, because when we are designing the dia of the pipe, we need to know what is the pressure creating the bottom of the tank. So that reasons we are doing this calculation. Same thing here, we need to calculate what is the energy, total energy, specific energy creating bottom of the tank. So specific energy is equal to potential energy plus kinetic energy. So next step is how we can measure that one. So we are having the formula q is equal to area into velocity. We know that one. Q means the water is flowing. For example, this is rectangular, for example this is one this is rectangular tank, right now. So u is equal to area into velocity. Area is what is the area? This is b and this is height, right? This is a cross sectional view, and this one is what we're showing, this is a side view, and this is the cross sectional view. This is the cross sectional view. So that reason we are getting breadth and height. That reason, that figure only we are getting h, because this is inside of the this is resting like this way it's having, and this is called side view. This diagram is like this, and this diagram is exactly this way. Height of the water also will get, and b also we get. And q is equal to area into velocity. Area is equal to b into h, we know, and velocity is there. Velocity we can find it on different method, and we'll get the meter cube per second. So meter cube per second. In that same thing here, one more is there, that is we can calling q, small q, that is capital Q, and small q, that is discharge per unit width. Discharge per unit width. It means how we can, what is that discharge per unit width means? Discharge per unit width means what? That is meter cube per second. Meter cube, that is meter cube per second. Meter cube meter into meter cube meter into second. So it means meter cube meter second. So it means this is I will explain. This q is equal to, for example, this is 10 meter cube per second. For example, q is equal to 10 meter cube per second. Q is equal to 10 meter cube per second. So small q is, how we can calculate this? Q is q by small q is q by area. Q is equal to 10 q by b, sorry, here is q by b, unit width, discharge per unit width. B is equal to, we can take it here, general, how much we can take it? 2 meter we can take it, 2 meter. B is equal to 2 meter. To how much? 5 meter cube. So what is the this one? This is in meter, and discharge is meter cube per second. So it means 5 this one 5 meter cube per second per meter. So that it becomes 5 meter cube per second into meter. This is 1 by m divided 1, we can say. So that is q is equal to, we can say q is equal to, we can say 5 meter cube meter into second. Meter cube meter per second. So now what is that? Now we got q is equal to, now we got q is equal to 10 meter cube per second, and small q is equal to 5 meter cube per second. What is the meaning of that? Small q is equal to 5 meter cube per second. So this is water flowing. So here small total 10 meter cube, that meter cube per second, it is 10 meter cube per second, it is discharging. But here the small q is 5 meter cube means per width, width means unit weight means it's 2 meter, total 2 meter. If they again 1 meter and 1 meter they dividing, and for 1 meter this is 5 meter cube, again the 1 meter, that is 5 meter cube. Total this 10 meter cube, 10 meter cube per second. That it's showing in this derivation. That's what I'm telling you. So that is the difference between q and small q, big q and small. That is the difference between small q and big q. And what one specific energy curve? What do you mean by this is a specific energy? And what do you mean by specific energy curve? Okay, there in the specific energy derivation, what I explained, that is a datum line, and here z is there, and plus h, height of the water, and plus v square by velocity, that is imaginary line. So the total energy, that is called total energy line. This is called total energy line, or specific energy line also. We can specific energy also, specific energy line also we can write it. Okay, specific energy line also we can write it. So it means here this is total energy, means total energy is z plus h plus v square by 2g. Here z plus h plus v square by 2g, and specific energy is equal to h plus v square by 2g specific length, because we are considering this one is bottom of the tank is considering is the datum line, so that is after specific energy is h plus v square by 2g. So after that, specific energy, potential energy plus kinetic energy, it means height, from the height what creating energy, that is height what energy is creating, that is called potential energy. From the velocity of water, what is the energy is creating, that is called kinetic energy. So we are having two q's, one is q, we are having q, discharge is equal to area into velocity, and this is the q is equal to meter cube per second, and small q is discharge per unit width, that we should know unit width what. So that is that unit is meter cube meter per second. What is the meter cube meter second, that I explained. Q, small q is equal to q by, it means discharge per unit width, this is the width. And suppose we are taken here q, capital Q is equal to 10 meter cube per second, and breadth is 2 meter. So it means this is the total water is flowing here in this rectangular width 10 meter cube per for 2 meter width. What every meter, what is the discharge, that we can say q, that is we are getting 5 meter cube per second. That is the derivation, that is that small explanation about specific energy. Okay, then what do you mean by specific energy curve, that I am explaining here. Specific energy curve means what? Specific energy curve, specific energy curve. So energy per unit width of weight of fluid, energy per unit weight of fluid, that is called specific energy curve. So that energy is we can energy is equal to joule energy per unit weight, when it means joule per newton. For example, 5 joule means unit weight of the fluid, which is 1 newton of the fluid. So the channel that is called a, what we can say, same thing. The channel bottom we are considering a specific energy, that we can what I discussed in this one here, this one is, then you can write it bigger diagram, channel bottom, and we are not considering the datum line. Channel bottom is a datum line, and this is a h, and next is the imaginary line, this is v square by 2g, that is this one is specific energy line, specific energy line. So next, sc is equal to what? h plus v square by 2g, right now. So that one potential head and this one is kinetic head. So here v is equal to, we can write it q square by s is h plus v square, h plus this one v is equal to, we can write q square divided by b into 2g, that we can write q square h plus q square b into 2g. Here v is equal to q is equal to a into v. So here q is equal to a into v. So this one, when v is equal to q by a, so q by a into a is equal to b into, so q by b is equal to q. So it means q by b is equal to we know the discharge per unit width is small q, so it means q by h. So it means, what is the answer? H plus, instead of q square by q square by b square by small q square by 2g h. So specific energy is equal to, that is small q. Okay, we should write this one is, this one is capital q square by b. So small q square by 2 q by b is equal to q square by 2gh. Okay, 2gh. So that is the equation. Here v is equal to capital Q by A, that is in meter cube per second by area. This is area is equal to B into H, and this is capital Q. So Q by B we know the small q by H. So it means q by B is equal to small q, because what I discussed before, small q is discharge per unit breadth. So this is the small q in divided by H. So this one is SC plus H2G H square. That is specific energy. H plus q square. Specific energy H plus q square by 2G H square. So what do you mean by specific energy curve? I am going to draw about specific energy curve. What is mean by specific energy curve? That I am going to explain here. Specific energy curve means it is defined as a curve which shows the variation of surface specific energy with respect to depth of flow. It is defined as the curve which shows variation of specific energy with respect to depth of flow. It is defined as a curve which shows variation of specific energy with respect to depth of flow. It means variation of specific energy with respect to depth of flow. So we know that we should draw two line. One is H and another one is specific energy. One is H and another one is specific energy. So here specific energy directly proportional to H. It will start from origin and its water height. It means it's directly proportional. It means directly proportional. When specific energy changes, height also changes. So I will draw it starts from origin. I will draw the angle that is 45 degree. It is H. It is potential energy. You can write P, potential energy. 45 degree angle. 45 degree angle. H is equal to potential energy. And next one, specific energy also directly proportional velocity and inversely proportional to gravity. That is also velocity variation. Specific energy also is directly depend on velocity, and that is inversely proportional to gravity. So that graph I can draw. This one is v square by 2g or kinetic energy. So here see, this is I am telling specific energy changes when it is maximum height. The specific energy also increasing, right now, and when it goes constant value, the specific energy, the value is increasing. Though that is velocity variation, velocity gradient. And next we'll draw that two are individual graph, and whenever we are combination of that two graph will come like, we'll draw like this way. This is H plus v square by 2g graph. This graph is H square plus v square by 2g. That combination of that two graph. Combination of two. And this depends on when the water is flowing this direction. Water is flowing this direction, its velocity, it means velocity is not constant, the variation takes place. So some, for example, this is the height, also variation takes place. Some obstruction is there, the water is going least and sudden gradual flow will takes place. So this one is h1 and this one is velocity head, and here different velocity. So this one like this way we will get. This one we can consider section 1 and this one we can consider section 2. section 2 2. So when it joins here, when we can joins here this one h1, and where we are getting the height, here height will get height will get h1, and it joins the specific energy line, here one value will get, and where it touches this point h1 dash, the same thing, two height will get here. The two height is possible, one is bigger height and another one is smaller height. The specific energies almost that is same, and that velocity will, that critical velocity, we can say that critical velocity, when critical velocity means water height reduces, specific energy also getting reduced. So critical height means that is critical pressure, it's something dangerous. And when it is reaches critical height, sometimes the gas also cannot for liquid. And water height, when it becomes reduced, water height becomes reduced, the specific energy, water height when it becomes reduced, the specific energy also lesser, and specific height when it reduces, energy increases. The same, the critical height, when it, the specific energy is minimum, when the specific energy is minimum, the critical height is the total specific energy will get reduced. Though finally what we need to calculate for maximum flow rate, what will be the specific energy, that we need to calculate. The maximum for maximum flow rate, what will be the specific energy, that we need to calculate in this equations. Okay, that's the combination of what I'm saying, h plus v square by 2g, that combination of that two height will get h1 and h2, where it is touches, then this is the minimum, and where it touches, that two heights will get, that we are calculating. And next we will going for that one, specific SE, we are having the formula, SE is specific energy, SE is plus q square by, we are having the formula SE is equal to h plus q square by h square into 2g, that equation we are having here. Now we'll go for the calculate the critical depth. For specific energy you will get two heights, h1 and what we discussed in that h1 and h2 is alternate depth, and minimum specific energy, when water height will reducing, the specific energy will increasing. That then what is the critical velocity and critical depth, what I am telling, that's how to find the critical height, that is very important here. And the critical height, how we can calculate, everything is depends on that. So here one more thing, here this is the minimum specific energy, what we can say, that specific energy minimum in this point will get. So that we can consider hc means that is critical height, that we can call it critical height. So according to that, this is hc, we can write it, this is hc, and above this one hc value we can consider, that is Froude number is equal to 1 here, and above the Froude number what we can say, and below the Froude number what we can calculating, what we know, that one what is we are studied before, that is this one is we calling above the super, that is we are calling subcritical flow, and below this one that is called supercritical flow. That is one subcritical flow and supercritical flow. Above the critical velocity, that is called subcritical flow, and and below the word one supercritical. And Froude number less than 1 is then called streaming flow or subcritical flow. Froude number is more than 1, that is called supercritical flow. Then that is we should know that those things, and remaining everything is same, that we should remember this all things. And next we'll go for critical height. What do you mean by critical height? That also I'm going to teach you now. What do you mean by critical height? what do you mean by critical height? So, or critical depth. So we are having the formula E is equal to H plus V square by 2G, right? And E is equal to H plus V square, we are written small q square divided by 2G H square, right? So here this is the height, this is the diagram I am telling, this is height and this is specific energy. So this kind of graph will get what we are discussed before, and here I said this is the minimum specific energy will get. I said no, specific energy minimum. I am drawing different diagram because that will confuse too much. So the specific energy is minimum. So here you draw one tangent. Why we are drawing the tangent means that is slope we will get when we deriving the slope, then deriving the slope and will when will become that derivation, that slope becomes zero, when that specific energy minimum value will get. So that we need to make it here. So how we can make the dE by dH is, it should be derivative with respect to d divided by dH is equal to 0, then that will be the specific energy. Specific energy is minimum. Here height unit, if it is changes, that's that energy won't change here. So that d by dH means what? How can E2 minus E1 divided by H2 minus H1. So here we are having E is equal to H plus Q square divided by 2G H square. This value we are having right now. So d by dH, d by dH, what will become 1 plus Q square by 2G H minus 2, right? So next this one 1 plus minus 2 derivation, when we will derive that Q square H minus 2 minus 1 divided by 2G. Next d by dA is equal to 1 minus 2 Q square divided by 2G H cube. So 2 will cancel. So what will becomes? So next this one 1 minus Q square divided by GH cube. So next Q square, I will write this one. Sorry, here small just it I will write here separately. Okay, 1 minus Q square, 1 minus Q square GH cube is equal to 0, and 1 minus then next Q square divided by GH cube is equal to 1. So next Q square divided by G is equal to HC cube. So this one Q square by G 1 by 3 is equal to HC, is equal to HC. then hc is equal to q square divided by z 1 by 3, and cubing both sides, what will become hc cubed q square by z. So hc cubed is equal to into g is equal to q square. So q square is equal to g hc cubed. Q square is equal to gs cube. So next I can use this one next for discharging per discharge per unit weight. We know q is equal to qb. So that is q, we know area into velocity divided by b. So b is equal to area into b into h into velocity divided by b. B cancelling each other. So next h into v. So we can h into v, if we can convert it for critical velocity, hc into vc. So next we are having the value of this is q, qc, hc, vc. So this one we can write, we are having gh cube we have right g, substituting the value, this one substituting value g hc cube, qc is equal to gs cube, okay, so hc square into vc square. So this will become this will become GHC is equal to VC square. So VC is equal to root of G into HC. This is the critical velocity. VC and GS cube H square minus VC square. Then how it when S square minus VC square. So here it's Q square is equal to Q square HC cube into Q square, S cube HC cube G into Q square. So Q square HC square minus VC square. So the final equation, critical depth VC is equal to root of G into HC. That is the final equation. So next, how we can calculate then specific energy minimum specific energy for critical depth. How we can calculate minimum specific energy for critical depth? For critical depth, how we can calculate minimum specific energy? Minimum specific energy for critical depth minimum specific energy for critical depth. Minimum specific energy for a critical depth. So formula E is equal to, we know, H plus Q square 2G H square small q, and E minimum is equal to H C plus small q square divided by 2G H critical square. So HC, we know, q square by G 1 by 3. So or HC cube is equal to q square by G. So substituting this value here, I can write it. I will write it here. Substituting this value, q square by G is equal to HC cube. So you substitute that value in HC instead of HC. So what will becomes E minimum, here this one you substitute here, E minimum is equal to HC plus HC cubed divided by 2H square. So this one will cancel it. So HC plus HC by 2 is equal to 3HC divided by 2. So final equation. Thank you very much.